Hey everyone, this is Scott from QuickBOM, and we're going to be picking up from where we left off in the previous video, Tutorial 1A, where we manually created an indented BOM for this skateboard. In this video, we'll be using CAD to drive the BOM instead of typing it manually. If you'd like to follow along, you can download the SOLIDWORKS files from the link in the comments as well as the SOLIDWORKS BOM template. This is our simplified model of a skateboard with just 4 parts: the board, 2 axles, 4 wheels, and 12 bolts. While this model is particularly simple, the same process can be followed for assemblies with hundreds or thousands of parts. In this example, our engineers have already filled out the custom properties of each part and assembly, so the BOM generation should be pretty quick. You can see the data by clicking File Properties at the top of SOLIDWORKS. Each one of these custom properties will get imported into your QuickBOM file, and you may choose to use some or all of them. Now we'll tell SOLIDWORKS to create a bill of materials, but we'll pay special attention to the settings. We'll use the table template, QuickBOM Example SW Export, which you can download from the link in the comments. Make certain that the BOM type is indented and we'll use detailed numbering. All other settings can be left as default. Hit the green check and place the BOM table somewhere in your graphics window. Right-click on the BOM table and click Save As. Change the type to Excel, give it a name, and click Save. Now we'll open the file that we just exported. This is what we'll import into your QuickBOM file. Before we can import it, we need to create a CAD-driven BOM in QuickBOM. Open up your QuickBOM file, the same one that we used in the previous tutorial, and go to the Instructions tab. Click Create New BOM. Last time we created a manual BOM, but this time we'll create a CAD BOM. Give it a name. You can't call it skateboard because that name is already taken by the manual BOM, so let's call it skateboard SW, short for SOLIDWORKS, and click Create BOM. This time it creates 2 tabs. The one called CAD_skateboard will be your indented BOM, and the one called import_skateboard will be where you can import from. Bring up your SOLIDWORKS export and highlight everything. Press Ctrl+C to copy and go back into your QuickBOM file. Paste this into your tab called Import_skateboard SOLIDWORKS. Here's a good time to pause and mention something about CAD imports. We've been doing this with a SOLIDWORKS file, but realistically, you can do this with an export from any CAD, PDM, or ERP system. The important thing is just the first 3 columns. The first column should follow this numeric outline format where children of an assembly are identified by appending a period and a new series of numbers. For example, 3.1, 3.2, and 3.3 are all children of 3. Quantity should always be in the second column, and the third column should always be the part number or any unique identifier. Database engineers would call this the primary key. Every column after the first 3 are completely optional, and QuickBOM will store and organize any information that you put in here however you like. If you can make your structured BOM from your CAD, PDM, or ERP system match this style, then you can import it into QuickBOM. Okay, let's get back to the creation of the BOM. Switch to the tab named CAD_skateboard-SW. Click Sheet Controls and a big dialog box will come up. Click Import from Import_tab. A dialog box will open up and let you know that you can do this import up to 5 times with a basic license. Click Yes to continue, or No if you want to save this use for a real project. QuickBOM will churn for a bit, and then you'll have a nicely formatted, indented BOM to work with. Let's take a look around. First thing to notice is that all of the information from SOLIDWORKS is now right here. Notably, there is a bit of information that is missing. The BOM from SOLIDWORKS had manufacturer and manufacturer part number in it. If we flip over to the Library tab, we'll notice that the information is stored safely here, but it's not shown in the indented BOM yet. If we decide that this information is worth showing in the indented BOM, we can do that by clicking Sheet Controls, Insert Column Header, select Column Type CAD, and select Manufacturer from the drop-down. Click Create Column. Follow the same procedure for the manufacturer part number. If you want the column to show up in a different place, just select it, right-click and click Cut, and insert where you want it. If there's a column that you don't want to show anymore, highlight it and delete it. All the data is still safely stored in the Library tab. As an engineering manager, one of the things that I like to do with my BOMs is to clearly assign each part to an engineer and give clear prioritization for each part. Then, it's as simple as pointing my team to the BOM file and telling them to work on the highest priority items. We already have a designer for each part listed, but we don't yet have a priority. Let's add that column now. Click on the column where you want to insert this new column, and click the Sheet Controls button. Insert Column Header, select Column Type Custom, and type Priority into the combo box. Click Create Column. Now, let's give a priority to each part by typing it here. Notice that there's already cost data over here on the right, but there was no cost data in the SOLIDWORKS files. Where did that come from? Well, it came from the manual BOM that we created in the previous tutorial. Each BOM or tab in Excel pulls information from the one Library tab, and this data was already in the Library tab. By keeping just one single Library tab, the same part can be used in multiple different BOMs throughout your QuickBOM file. This is super handy for things like bolts and other common components. A purchasing person can get a quote for one M6 bolt, update the cost, and that cost will automatically make its way to all the indented BOMs in the file. Closer inspection shows that one cost is missing. There is no cost for the bolt. If we move over to the man_skateboard tab, we'll see the error. When we made the manual BOM, we accidentally called this part bolts with an S at the end, instead of bolt with no S. Let's change that here and re-add the cost. During months with lots of design work, I like to re-import the BOM from SOLIDWORKS every few days. When I do that, it will refresh the structure of the BOM and every one of these teal colored columns with the word CAD above the header. But it will keep the orange columns where I entered my custom data. So if my purchasing team updates the cost for an axle, and then I import a fresh BOM from SOLIDWORKS, that cost information will be maintained through the import process. Now, let's go over to the Library tab and take a look at a few things. Notice these gray columns with flat quantity in them. These are the flat quantities in each Bill of Materials tab. Let's move them closer to each other. You can always reorder columns in any of these tabs. When you give this list of parts to purchasing, it's often nice to sort and filter them. Highlight row 2, remove the old filter, and add a new filter. This is a basic Excel function that works really well in QuickBOM. You might have the Library tab filtered to just one supplier, or you might sort them by the highest cost to the lowest. A lot is possible in this tab. Think of what you want to do and experiment with it. Lastly, notice that our bolts typo part is still on the Library tab. This is intentional. The Library tab contains all parts that ever existed in the indented BOMs. This is helpful for parts obsolescence. You can't know that something is obsolete if it just straight up disappears from the list. Notice though, bolts with an S has a flat quantity of 0 in both BOMs, which indicates that it's obsolete. It no longer appears anywhere in the indented BOMs. This concludes the basic tutorials for QuickBOM. You should now have all the information necessary to get started with your own BOM for your own design project. If you would like, continue on to tutorial 2, where we'll be covering advanced topics. We'll take a look at a SOLIDWORKS file with 2 configurations and see how it links to a manually created BOM with spare parts and components that don't traditionally get modeled in a CAD drawing, such as hoses, wires, and electrical components.